talk about investigating bonsai as an alternate curriculum for teaching botanical science to school-age children. By the way, probably she's the only undergraduate speaker, so I really appreciate your effort.
Thank you.
Yeah, you're doing a great job. Okay.
Thank you.
Lindsay.
I would just like to say what a privilege it is to stand in this room and say that the fact that there's so many people in one place that love plants as much as I do is amazing. When I shared with my family that I wanted to study botanical science, my dad said that was absolutely no surprise to him, that I'd always loved playing in the dirt and that nothing had changed. And although I still do love to play in the dirt, I think we can all admit that botanical science is a little bit more than just that. So I'd like to begin my talk with a little background on what is bonsai and its rich history and its potential involvement in education. The term bonsai is directly translated as tray tree or grown in a container, and it's the restricted growth of a plant to less than a meter in height. It can be a tether to our past, an art form, and a rich opportunity for education. Bonsai's history dates back to 960 CE in China during the Song period, and was later adopted in Japan during an influx in Buddhism almost 1,200 years ago. Its first appearance in Western culture was in tales from travelers from the East talking about these ornate gardens of miniature trees. Its first official appearance on Western soil was during the 1876 Philadelphia Expo and had other appearances in France and Great Britain. As many of the presenters prior have discussed, plant blindness is a major issue, and it's almost an issue that is preventable. It is an issue that is preventable, and plant blindness is the lack of acknowledgement of plants in people's daily lives in reference to animals. And this is attributed to the fact that plants don't have faces or human-like characteristics that people, and especially children, often identify with. A primary example of plant blindness, these are 4 different food webs that are actively used in education, teaching the references between organisms and how they interact with each other. And if you'll notice, there are very specific common names for animals used on these webs. But when it comes to plants, the word plant is only used, and in this one, plants are not even talked about. And seeing that there are approximately 400,000 different species that we know of today, this is an overgeneralization on a huge scale. So plant blindness is definitely apparent in the classroom. Plant blindness can lead to other issues on a larger scale, a global scale. Research put out by the Food and Agricultural Organization shows that by the year 2050, we'll need to increase our food production by 70% to accommodate our growing population. These issues, we think that early awareness is the key to this. If you teach a child to love a plant early on, they're more likely to appreciate its significance and want to conserve it later on in life. We believe this is possible through an engaging and interactive curriculum in the classroom. If you speak to educators and students about plant science in the classroom, at some point the word bean is going to come up in the conversation. And for some educators and often students, an eye roll or an exhale is followed by that. This is because, to some degree, the luster has been lost with the bean curriculum. Students are no longer engaged, they're not interested in what you're trying to teach them, and teachers are exhausted by this. So, is there a way to create that interaction between students and plants and the educators? Well, I'm so very glad that you asked, because to every great research, there's a specific question. And to that question, there's a specific set of goals that accompany it and how to reach that goal. And our question is there another way? Is there another way to teach botanical science in the classroom? And so we have 2 main goals that we are using to answer these questions. And the first is discovery. We're trying to discover and analyze various plant species to find the one that's best suited to the classroom, that allows students to engage in growing their own plant and often bonsaiing and pruning their own plant to see various botanical processes. We have a criteria that we use. Is the plant quick to germinate? Does it quickly grow? Is its care simple enough to grow in a classroom? And does it require little care or knowledge on the part of the teacher? Secondly, development. To develop a curriculum that is paired to as many next generation science standards as we can, that makes the teaching of botanical science fun and interactive. So in any great research project, you have to evaluate what you have and what we can provide. And what we started out with was 24 individual species. 12 of those have germinated. 8 have undergone initial bonsai pruning, 5 of which are coincidentally part of the Fabiaceae family. And we have application of over 100 next generation science standards. What can we provide? We can provide a simple and efficient and effective curriculum that covers a large amount of next generation science standards that is engaging and interactive for the students. All right, so I'd like to take you through a sneak peek of a potential bonsai curriculum and just let you see some of the benefits that can be gleaned from growing a miniature tree in the classroom. And for simplicity's sake, I'm going to use our beautiful earpod tree as an example. So observation is one of the most fun parts of learning for the student. It's the part where the educator stops teaching and the student's given the opportunity to learn in their own unique way. Some various ways of observing is data collection, through seed and seed preparation data, as well as addition and subtraction, measurement, statistical analysis, and various other forms of observation. As you can see, here's some microscopic observation that can be used with these bonsai specimens. Documentation. This is an example of some of the data that your students may collect, and this is some of my data specifically. And I'd like to point out 2 sets of numbers to you. The first is the initial seed weight in comparison with the seed weight after preparation. This is a 300% water uptake, which is important. And also the average seed height at emergence versus the average seed height after 21 days post-germination. These are very important characteristics in your data collection because they're quantitative ways for a student to see biological processes such as water imbibition and primary plant growth. They can see the data on the sheet and say these things are happening. They actually really are happening. Here's some other ways that documentation can happen in the classroom. Drawing and labeling, as well as photography. I think that's a very underused method of documentation, one that I love. And lastly, the moment that all the educators in the room have been waiting for, the implementation. So the implementation for us was to take the next generation science standards and pair them to our work. We've also been able to pair connections in social studies as well as math. Some examples of these are the relationships between animals and plants and ecosystems, inherited traits, measurement and data collection, statistical analysis, geography, environments and societies, to name just a few. This is our beautiful earpod tree. This is 120 days after planting and 102 days post-emergence. And as you can see, this bonsai has already taken on a beautiful and unique weeping form in a very short amount of time. It's already undergone its 2nd bonsai pruning event as well. Why does this matter to me? Not only do I love plants and it's my area of study, but this has a very personal component to it for me. My grandmother was a whiz in the garden. There's nothing she couldn't or wouldn't grow. And I feel like I owe it to her to keep on her legacy of her love of all things botanical and to teach others about it. Secondly, I have children in the school system who are directly affected by the plant blindness that occurs. And I feel like for my children, I want to leave a lasting contribution. And not only for my children, but for all children. And I know as educators that this is your goal too. So I invite you to take part in my endeavor and our endeavor to create a botanical curriculum that is engaging and exciting for students, that spawns them to want to learn about plants. I'd like to acknowledge my university, Armstrong State University, as well as the undergraduate research program where I received funding. Also the Parkersburg Garden Club, who I also received scholarship from, and Dr. Melanie Lake Perez, my co-author and mentor. Without any one of these, I could not have done this research, and I appreciate your time.
I think we should clap for the next 5 minutes because we have 5 minutes for the questions.
I was told to keep
yes,
it.
wonderful, wonderful talk, and some of the words you said very touching to some of us who sometimes forgets what we do. We just are confined to a little lab and do research and even don't do outreach. Don't talk about future children and that sort of things. Thank you very much for that. Now, floor is open for questions. Wow, I see many hands up.
Okay.
Carol.
Oh, okay. So my problem with bonsai is that my plants, they always die.
Okay.
Is that an issue that comes up when you're working with?
I have one question. Are you growing your bonsai from seed or are you purchasing it?
Not purchase, more like seedlings, yeah.
Okay.
Like I would take things from the yard and try to
Yes.
bonsai them.
And I've done that as well and had some difficulty. I think the difference is these seeds were planted and the seedlings emerged and were grown in a classroom environment. They were grown in the environment that they are intended to live, which I believe is very important to the success of the plant. So, and we've had some not great successes along the way.
I guess that's really my question, is
Yes.
is that a problem at all with kids, like the disappointment of their plant dying?
Yes, I can imagine that as a child that might be a little disconcerting, but you know, as a class you're growing many and you're given the opportunity, you're going to plant more than one, and you have the opportunity to choose the best one from. So out of 8 seeds, you're going to have a success. So that's...
So it's been easier than it sounds. Yeah.
Yes,
Yeah.
yes.
Good.
I knew absolutely nothing about bonsai when I began this research. Nothing. And Dr. LP said, hey, we want to do this. And I said, I'm on board. So, I think you have a question.
Well, I am I'm more ignorant about bonsai than you are. And I was just wondering if we had time, if you just tell us, what does a pruning event look like?
So a pruning event involves, you can do it as soon as you're moving your plant from the initial germinating tray into a training tray. And these training trays are very shallow, and the purpose of that is to develop the superficial roots and not those deep, hardcore roots that uptake, that can cause the plant to grow much taller. So basically what you're going to do is you're going to remove your plant from the potting mix, and you're going to look at your roots and say, which roots do I want to keep? I want to keep these superficial hair-like roots. I want to get rid of that big root at the bottom. And those roots will multiply over time, and you're training the smaller roots to take over. And then you want to do some trimming off the top to ensure that your plant has success because you've removed a mass amount of roots. So it is not as complicated as it appears. I've actually taught this to a lab, my other fellow lab students in horticulture, and they all rolled their eyes when we said we were going to bonsai. And at the end, they were like, "Oh, this is really fun. Do you have any more plants that I can do?" And so it was really a great way to interact with my fellow students. Thank you so much.
Yep, I think we are running out of time.